we're cutting this portion of the signal. Yes or no? We are getting only this part of the signal. So this portion is cut or clip. Understood? So I'll design one circuit where the red one is the input and the pink one is the output. Right? So red one is the input and pink one is the output. So in that process, we are cutting or clipping some portion of the signal. Here it is full half cycle is cut, negative half cycle is cutting. So this circuit is called as clipper circuit. Understood? Similarly, if you want to cut positive half cycle, that is also possible. Suppose I want to cut positive half cycle. So I'll get only negative half cycle here. So this positive half cycle will be cut. Or if you want to cut some portion of the signal like this, and if you want to cut only this portion, I'll get from here to here, here to here, like that also possible. So any circuit which will clip or cut some portion of the signal is called a clipper circuit. Very clear?
Yes, sir.
Now, what is the practical application? Sometime you have seen, like if you go in a travel, so that vehicle owner have fixed the speed limit. The driver can increase the accelerator, but after 60 or 70 km per hour, the speed will not increase. So that is the maximum limit which is set. That means it is clipping that portion. Even if it is increasing after 70 km per hour, it is not actually increasing, it is clipping. Okay, so that type of thing we can use. Even half wave rectifier also one best example, because half of the input is we are cutting for our requirement. That means AC is converted to DC. So you can say this is also one application of or type of clipper. Now see what are the different type of clipper are present, and one by one we'll see. If you define or if you classify the clippers depend upon the which portion is clipping, so either two type of clipper will find. One is positive clipper and another one is negative clipper. Okay, positive clipper and negative clipper. Positive clipper means it is clipping positive part. Negative clipper means negative part is clipping. Okay, another one is biased clipper. We'll see individually. Biased clipper means it is not fully clip half cycle, means positive half cycle or negative half cycle. It will clip part of positive or negative cycle. Okay, like this example I have shown, this is your fully clipping, so it is negative clipper, this is positive clipper, and this is biased clipper. Because it is not clipping full cycle, it is clipping only this portion. Understood?
Yes, sir.
Now, this is regarding the output waveform. Another classification is there, depend upon the diode connection. How the diode is connected across load. if the diode is connected across load in series, then that is called a series clipper. And if the diode is connected in parallel with the load, then that is called as parallel clipper. So we can combine this series parallel. So you can combine with these positive, negative, and bias with this series and parallel clipper. That means series positive clipper, series negative clipper, parallel positive clipper, parallel negative clipper. Similarly, bias clipper also you can design. So let us see one by one how to design the circuit. Even in the exam, you will get a question like a circuit diagram will be given and input will be given. You have to find the output waveform. Okay, so like that we'll discuss here. Very simple circuit I am taking. First I will take a input. So this is my input signal. All of you bring your copy. Just don't see this one, because even if 100 question I'll solve it here, the 101 question if I'll give, it will be difficult if you not practice. So all of you take copy and draw what I'm drawing. Write the process, try to understand the process and try to solve here itself. So this is my input. Now what is the circuit? I'm giving the input to this circuit. Very simple circuit. Already we have discussed this one, but other name I have given. Okay. So here I am giving the input where diode is connected. This is the RL or R. Let us take only R. And here is the output voltage. Okay. So you have to find the output voltage and draw the output waveform. This is the question. Now, how to proceed with this type of problem? First, we need to, we know what is the circuit, we know what is the input. Now, if I give this input to the circuit, then what should be my output? That I need to find out. So, first consider the diode is ideal diode, because nothing is mentioned. So, first we will consider this diode is ideal diode. And there are different steps, means how to proceed with this problem. First step is find the condition to turn on diode. First you have to find the condition. Okay, at what condition diode is on, at what condition diode is off. Second step, draw equivalent circuit for each case. Each case means when the diode is on, when the diode is off. Two diagram you have to draw. Third one, apply KVL to find output voltage in each case and plot it. So this three step is very critical. You need to understand how to do it. Circuit is given, input is given. First you need to find out what is the condition when my diode is on, when my diode is off. Once you know the condition, then draw its equivalent circuit, then apply KVL, then draw the output waveform. So let us proceed with that. So first step, find the condition. So can you tell me what is the condition when the diode is on in this case? What I'll give here so that my diode is on? Positive half cycle or negative half cycle, or V is 5 or minus 5 or any value? Just tell me. At what condition my diode is on? At what condition my diode is off in the circuit, given circuit?
Sir, the positive half cycle.
Positive half cycle means V greater than 0.
Yes, sir.
When V, I can say for Vi greater than 0 volt, diode is on. Yes or no?
Yes, sir.
This is the simple half wave rectifier circuit. Okay, this is the only, without the naming I am explaining this one because this is the simple one and will modify the circuit to make more and more complex if you understand this one. Now in that case, if I want to draw the equivalent circuit, diode will be short circuit, then resistor. So here minus plus, let's take Vi, and here plus minus V naught, here R. Now apply KVL. So this is the first step, drawing the equivalent circuit, third step. Now applying KVL is the third step. So what is my third step? If I put it here, minus to plus, plus Vi, plus to minus, minus V naught.
सर फर्स्ट केस समझ में नहीं आया.
कौन सा फर्स्ट केस?
सर फर्स्ट जो कंडीशन निकालना.
ये जो सर्किट है ये ऑन कब होगा? हाफ रेक्टिफायर पढ़े थे ना, कैसे डायोड कनेक्टेड है? यहाँ पे इनपुट डायोड दिया हूं ना, इनपुट यहाँ से दे रहा हूं, ठीक है? तो डायोड फॉरवर्ड बायस कब होगा, किस कंडीशन में? अगर ये मेरा इनपुट है तो
फॉरवर्ड बायस.
हाँ, तो फॉरवर्ड बायस कब होगा, किस कंडीशन? हाँ,
पॉजिटिव हाफ साइकिल.
positive half cycle. Positive half cycle means that is V greater. This is my V in. Okay, so positive half cycle means this region. This is greater than 0 or not?
Yes, sir. Yes.
Understood? For V
Yes, sir.
greater than 0, or you can think like that. When I am giving this input here, the negative side of the diode is connected to here and positive is connected to here. Now when it is increasing, that means this is plus, this is minus. So plus is connected to anode, negative is connected to cathode, or anode is higher potential, cathode is lower potential, then diode is short. Understood?
Yes, sir.
Now V naught, how much? Vi. Clear?
Yes, sir.
Now for second case, on condition is over. Now for off condition, for Vi less than 0, D is off. D is off means what is the equivalent circuit? It is off. Okay. So this is your V naught R plus minus Vi. So what is my output voltage? Tell me. I have drawn the equivalent circuit. What is my output voltage? Is there any current flowing in this circuit?
No, sir.
No, sir.
Current 0, so V naught equals to 0. So we have found the condition. This is the condition, first condition. This is the second condition. Then draw the equivalent circuit. This is the equivalent circuit. Third one is apply KVL. I have applied KVL there. I have applied KVL here. Finding the output voltage. Then plot the waveform. Just a minute. Now, can you plot the waveform? Once you get the voltage, very simple. So if this is my output voltage, is time. So what we got here for positive half cycle? We need
positive one. Positive high side.
for positive half cycle we are getting, negative half cycle it is 0. Then again positive half cycle, then again negative half cycle. This is your 0, this is your Vm. Okay, so this is your output. So same thing already we have discussed in half-wave rectifier circuit. So this is like a half-wave rectifier circuit, but I want to show you the steps. So this is very
Sir.
simple circuit. Yes.
Sir, can you explain the second condition, sir? I got disconnected, sir.
Second, you have understood first condition.
Yes, sir. Yes, sir.
Now for negative half cycle, if I am giving plus here, minus here, then what is the diode condition? Off or on?
Sir, off.
Off means open circuit. I have drawn the equivalent circuit. So current will not flow. So output voltage will be 0. Okay.
Yes, sir. Yes, sir.
So for positive half cycle, we are getting output voltage as input voltage. Negative half cycle, output voltage equals to 0. So that I have drawn here. So this negative half cycle is clipping here. So this is for practical ideal diode. Now you can take this one, the same circuit to find out.
Sir, can you show that graph? Second page. Graph. Yes. Sir, can you explain this one?
You see this one, have you understood this one? You try to plot V naught equals to Vi for positive half cycle.
Yes.
V naught equals to 0 for negative half cycle. That's what I have done. For positive half cycle, V naught is changing as V in, and for negative half cycle it is 0. Again positive half cycle it is changing as V in, negative half cycle it is 0. It will continue as it is. Clear?
Yes, sir. Yes, sir. Clear, clear.
Now I'll give another same type of question. Let us see how many of you have, how many of you will do. I'll take a diode here. This is the threshold voltage of the diode is Vf. Okay, it is not ideal diode, practical diode whose threshold voltage is Vf. Resistor. Then this side input. This side is output. This is R, and input I am giving as a square wave. Okay, try to solve same way. I'm giving 3-minute time. किसी का हुआ? नहीं हुआ?
सर एम्पलीट्यूड कम हो जाएगा, बाकी तो सेम रहेगा ना।
हाँ, एम्पलीट्यूड कम हो जाएगा। तो उसको कैसे करेंगे? फर्स्ट कंडीशन, you have to identify when the diode is on. So what is the condition? If Vi is greater than Vf, then only the diode will be on.
यस सर।
Then D is on. Now I'll draw the equivalent circuit. So in place of diode, I'll not take short circuit. I'll take a voltage source whose voltage is Vf. Then resistance R. Then plus minus V naught. Here Vi, then apply KVL. What will get here? Vi, then this is plus minus, so minus Vf minus V naught equals to 0. So V naught equals to Vi minus Vf. Understood?
यस सर।
क्योंकि टर्न ऑन करने के लिए मुझे Vf चाहिए, सपोज आई विल टेक सिलिकॉन डायोड, तो 0.7 चाहिए टर्न ऑन के लिए. So my condition is whenever V in is more than 0.7, then only the diode will be on. अगर मैं 5 वोल्ट दे रहा हूँ, 0.7 स्पेंड हो रहा है ऑन करने के लिए, बाकी 4.7 रहेगा. So that will be come across the output voltage. What is the condition for off? Vi less than Vf होगा तो क्या होगा? D is off. D off होगा तो it will be off, means open circuit.
Yes, sir.
So plus minus Vi plus minus V naught R. So current will be 0. So V naught will be 0. Now how to draw the waveform? First I'll draw time and voltage axis V naught. So here I have represented Vm is my maximum voltage. So here Vm minus Vf. Yes or no?
यस सर।
Then for negative half cycle 0.
Zero.
Again positive half cycle Vm minus Vf. Like that it will continue. So you should write here the condition applying KVL in the loop. I am not writing that one because it will take more time. So I am not writing. But while you solving, you have to write it. Okay. Here applying KVL like this. In this condition, equivalent circuit applying KVL, output voltage, and this is the output waveform. Like that you will write. Everyone has understood this one?
Yes, sir.
Now I'll give another question. I'll just reverse the diode position like this. Take ideal diode and try to solve it. Input, let us take again square wave you take. Quick.
सबसे नेगेटिव साइड में रहेगा।
हाँ वो है, but after this I'll more complex this circuit. That's why you need to follow the process. Okay, stress and process.
Okay.
Diode is reverse means obviously the positive side will be clipped, but I want to focus more on process so that next time I'll little bit complex it, will able to solve. So you try to solve in your pen and paper, or if you have system like this, you can also solve and share your screen, no problem. Here for Vi greater than 0, diode will be off. Vi less than 0, diode will be on. Yes or no?
Yes, sir.
Yes, sir.
For Vi less than 0, D is on. Less than 0 means it will be short. Okay. So here Vi, what I am getting here, minus Vi minus V naught equals to 0. So V naught equals to minus Vi. Then for Vi greater than 0, diode is off condition. So it will be open circuit, then resistor minus plus Vi, then R, then here V naught plus minus. So as current is 0, V naught equals to 0. What is my output waveform? T V naught. So for positive half cycle, I am getting 0. For negative half cycle, again positive half cycle 0, again negative half cycle, it will continue like this. This is 0 and this will be minus Vm. Got it? Who are not able to understand, ask me. Everyone has understood?
Yes, sir.
Yes, sir. Okay. Now, I'll give another question. Little bit twisted, which is biased clipper. Okay. So, see here, input voltage is changing from minus 10 plus 10 AC signal. Before diode, one 2 volt battery is connected. Now you have to find out output voltage. So this is your biased clipper. First you need to identify at what condition the diode will be on, at what condition the diode will be off. You analyze and tell me at what condition diode will be on and what condition the diode will be off. Take diode as ideal diode.
Vi greater than 2.
Very good. What is your name?
Ayushi.
Okay. So tell your friends how you will understand greater than 2 it will be on.
So because at Vi greater than 2, it will the current will flow in positive direction from D.
No, that is okay, but how you analyze that when I give more than 2 it will be on?
So because the current moves from positive potential to lower, that is why. Greater than 2 means it will flow in the positive direction.
Answer is correct, but logic is not valid for all. So you see here, in two logic you can understand the condition. First thing is, when I have not taken this 2 volt here, suppose I will not take this one and take here as practical diode. What is my condition? When Vi
VI greater than VF.
Vf, then diode is on. Now 2 volt is series with this Vf. Okay, so let us take 2 here, 2.7. So how much voltage I require to turn on?
2 volt.
Sir, more than 2
2 volt and 0.7 is in series.
We'll add it.
We'll add it. So
2.7.
it required 2.7 volt, more than 2.7 volt. Now if you take, this is ideal diode, this 0.7 is 0, so I require more than 2 volt. That is one way. Other way, let me clear this one.
So can you explain this again?
See here, let us take cut this circuit from here. Okay, and this is my anode. We know anode potential must be greater to turn on the diode. P side में more than 0 and N side is connected to ground, means if Va is or potential at anode is more than 0, then diode will be on. Yes or no? When you take any diode, what is the condition to turn on? This is anode, this is cathode. So Va must be greater than cathode. हाँ कि नहीं?
Yes, sir.
Yes, sir.
Now if it is 0, then Va must be greater than 0, then diode is on. So here that logic will apply to find this one. So anode voltage must be greater than 0. Now here this is my Vi, and if I find these 2 points and apply KVL, what I'll get? Vi, this is plus minus means minus 2 must be greater than 0. The potential at these 2 points, this and this point, must be greater than 0. So before that, what is my potential? If I apply KVL, Vi minus 2, that must be greater than 0, so that my diode is on.
Yes, sir.
I can write Vi must be greater than 2 volt, then my diode is on. Okay, and Vi less than 2 volt, then D is off. Understood? Now let us draw the equivalent circuit. When Vi greater than 2 volt, what is my equivalent circuit? 2 volt, then I'll take ideal diode, then resistor minus plus Vi 2 volt R plus minus V naught. Apply KVL here. Tell me what is the equation? minus 2 plus Vi minus 2 minus V naught equals to 0, V naught equals to Vi minus 2. So इनपुट वोल्टेज जैसे जैसे चेंज होगा उससे 2 वोल्ट लेस मेरा आउटपुट होगा, है कि नहीं?
Yes, sir.
Now if Vi less than 2 volt, then it will be remain as 2 volt here. Is it open? V naught I equals to 0. So V naught will be how much? What the voltage here? If current is not flowing,
0.
0.
now once you do this one, the 3-step over, but till now we have not drawn the waveform. So see here how we'll draw the waveform. I'm taking a bigger picture here. Okay. Now this is your input and this is your output. Output I am drawing using blue line. So what is my reference line? 2 volt. Whenever the voltage is more than 2 volt, diode is on. Less than 2 volt, diode is off. So I'll first draw the input 2 volt line. So let us take this is my 2 volt. ओके तो जब जब इनपुट वोल्टेज 2 वोल्ट से ज्यादा हो रहा है, ठीक है, देन व्हाट इज माय आउटपुट वोल्टेज? आउटपुट वोल्टेज इज Vi minus 2 और इनपुट वोल्टेज minus 2 volt. Whenever it is less than 2 volt, output voltage is 0. So that I need to plot it here. That means I can plot the graph like this. This is 2 volt line. So whenever my input voltage is less than this region, output voltage is 0. Okay, let us take, this is my line. Now whenever it is more than 2 volt, that means after this my output voltage is changing as input voltage up to what? Next, जब तक ये 2 volt से कम नहीं होता है, तो input voltage changing like this. Then whenever it is going less than this point 2 volt, then output again change to 0 till next 2 volt increase. So up to here again it is, then again it is changing up to this point, then again 0 like this. Understood? So basically what we are detecting this one. So this part below that, this pink line, it is cutting. So I can say this part actually cutting. Yes or no? This part actually cutting. So what is the voltage from here to here? 2 to 10 means how much?
8 volt.
8. So actually in the output it is 2 volt is changed to 0 volt, 10 volt is changed to 8 volt. So this is my 0 volt, this is my 8 volt. Okay. Here also you can take, if I take Vi max is 10 minus 2, that is 8 volt. Understood? So you can directly from the input you can, if you visualize then it is okay. Like this you can visualize and you can draw this waveform like this. Okay, otherwise you can take another waveform below and you can draw like this. In the exam you have to draw input and output. This is my requirement. Is it clear?
Yes, sir.
अभी मैं तुम्हें एक क्वेश्चन देता हूं. ये जो वोल्टेज है इसको सेम इनपुट सेम एवरीथिंग, ओनली आई चेंज दिस टू रिवर्स वोल्टेज, मीन्स like this. So it will become -2 or not if I change the polarity. Now try to solve this question. If you understand the process, then you can easily solve this question. So process is very important. Why I'm saying, because in place of sine wave you can take triangular wave, you can take square wave, you can take ununiform, like here I have taken 0 to 10 -10. You can also take upper 15 degree 15 volt, niche 5 volt, or even upper side 5 volt, below side or downside -15 volt. So any type of things can be possible. Instead of 2 volt you can take 5 volt or 3.5 volt. Even you can take practical diode. Everything is possible. Number of question you can frame, but the condition is same. You have to find out the condition, then draw the equivalent circuit, apply KVL, then drawing the output waveform. This 4 step you follow, then any question is easy. So try to solve this question. Tell me what is the condition first. At what condition my output voltage or diode will be on? बोलो कंडीशन, बोलो जल्दी. इतना टाइम लोगे तो कैसे होगा? At what condition, like here Vi greater than 2, diode is on, less than 2, diode is off. In this case what is my condition? इनपुट क्या होने से डायोड ऑन होगा, इनपुट क्या होने से डायोड ऑफ होगा.
तो Vi लेस देन -2 कुछ आ रहा है तो वो तो ऑफ होगा उस समय.
Vi लेस देन -2 होगा तो ऑफ होगा, तो उसका उल्टा होगा तो ऑन होगा.
यस सर.
So how you have found out?
So when -Vi -2 greater than 0 should be greater than 0.
Vi plus 2, because I am moving in this direction.
Should be greater than 0.
Vi plus 2 should be greater than 0. So Vi greater than -2, then D is on. If Vi less than -2, then D is off. Now once you find this condition, then draw the equivalent circuit and find the output voltage and tell me how the graph will look like. Everyone has understood this condition, how we have found out?
Yes, sir.
Now, like we have found out this two equivalent circuit and apply KVL, same way you find and tell what is the answer. कहाँ से कट होगा मुझे बताओ.
Sir, -2.
-2 से कट होगा. So the have you draw the equivalent circuit and proceed?
Yes, sir.
So we'll get like
V नॉट इक्वल टू VI प्लस 2 हो जाएगा.
हाँ VI plus 2 हो जाएगा. So graph will be like this. Okay. So here to here how much? This will be 0. This will be 12.
Well,
So you will get the graph like this. This is 0, this is 2, this is 12, V naught, T. This will be not, this point is your T by 2. This is not T by 2, okay? So T by 2 somewhere here. Somewhere here. Understood? Why I am not taking that one? Because I am getting the voltage at this point, which is दूसरा वाला थोड़ा पहले होगा, यहाँ पे होगा. अभी मैं 2 टास्क दूंगा, तुम घर में करना. 2 नहीं 4 टास्क देता हूँ तुम्हें. Same question, what we have solved. You take till now you have taken this is ideal diode. Now you take silicon diode. Okay. So this combination and one combination we have solved like this. So 2 volt and this is silicon diode. Same input 10 minus 10. और उसके बाद क्या करना है, डायोड को रिवर्स कर दो. Diode will be like this, 2 volt and like this, 2 volt diode. Okay, and we'll solve this one and tomorrow we'll tell what is the answer. Have you understood? Only the same question what we have solved, same question with practical diode or silicon diode you take, so 0.7 will be added. So instead of 2 it will be 2.7, nothing change. And when you change the diode, you take ideal diode again and try to solve it. So instead of greater than you have to take less than.
So these 3 questions, no? You have to do.
1, 2, 3, 4. Now if you want to more, then you can take practical diode, then it will be 6. So that's why number of question you can frame. If you change the input, again 6 question you can set. But follow the step. The process is same. If you follow the process, then it answer will be same. So all these are series clipper because diode is connected in series with the resistor. You can see here diode is connected in series with the resistor. Tomorrow we will see parallel clipper, means diode will be connected parallel to the resistor, then what is the output voltage. Just wait, I'll take the attendance.
Yes, sir.
Don't leave the meeting. I tell when to leave. Okay. So attendance is taken. Now I will leave. And while you come tomorrow, you practice means first show me the result. Okay.
Yes,
Thank
sir.
you.
Okay, thank you, sir.
Okay, sir.
Thank you, sir. Okay, sir.
Thank you, sir.
Thank you, sir.